Okay, so obviously that shouldn't be parabola. I didn't edit that. I should say ellipse. Sorry. Okay, so the ellipse thing, okay, as it says up there, if you went through all the stuff with the parabola, right, you had one focus point you worried about a vertex, right, because that's what parabola is at. Parabola has a vertex, one focus point, and then they had another thing called a directrix, which was a line. Okay, you were just staying, every point that was on the parabola was equidistant between that line and the focus point. All right, now you move to an ellipse. Okay, ellipse, you guys should already have an idea, guys. Ellipse is like your oval, right? It's basically same kind of form, equation-wise, as a circle. The difference is now, since it's like kind of a squash circle, it changes from just being a fixed set of points equidistant from a center to now it's the, you can see the sum of the distances from the two fixed points being the same thing. All right? So with this right here, your standard form for your equation, and again, you're going to have two different types of the ellipses here. You're going to have one that is horizontally longer, which I mean like it looks like it's stretched out along the x-axis, and then you'll have a different equation for one that's stretched vertically. Now they're going to look almost identical. Okay, like there's going to be one subtle difference between these, and that's where the a squared and the b squared go. Because in the formulas that we have up there that I'm writing out, the a is always going to be a bigger number than b, and it's always, both of them have to be bigger than 0. Because if it was 0, you can't divide by 0, it'd be an undefined thing. All right, now all the rest of those things there are just telling you how to find vertices, the foci.
Is this Japanese?
It's foci. I've always said foci, but if you look it up, there's two pronunciations. It depends on what group you're going through. And you're also going to have the major and minor axis. Major axis would be the length between the two vertices that you found. The minor axis would be how far it is from like the shorter portion of it. So if you had it graphed out, okay, this would be kind of what it looks like. Right. All right, so what they're saying is that for this to be technically a ellipse fitting the definition, where these points are located, these are the two focus points. If you were to draw like a distance from here to each point, these two added together, these two lengths, would be the same no matter which point I pick. So if I pick a point here, those two lines would be the same sum. These two lines right here, those would be the same sum. Okay? That's kind of how these ellipses are formed. All right? You're still going to have a center point. We're not dealing with this being shifted right now, so all your centers are at 0, 0. That's why if you look at another part of the book, you'll see that the formula is going to change a little bit, or the equation, not formula. And you'll have parentheses up here, but you have to deal with that today. All the stuff you deal with today, and even on Wednesday when we do the hyperbola start, we're all going to deal with it being centered at the origin. All right, it's all going to be a little easier. Okay, so just remember, you still have a center point. You do have a center, just like a circle. All right. And just take into account, guys, that the two focus points are always inside the ellipse here. Just like if you did with the parabolas, you were to see, like, graph them. If that was my parabola, the focus point would be somewhere in here. And you had that other line that was like the director somewhere below that vertex. The focus was always inside it. Same thing. So again, same thing that was up there. All right? The only difference is don't write everything again. Just kind of change it so you understand this is if the ellipsis turns, so it's longer going up and down as opposed to left and right, horizontal. So the only thing that's going to change is now the larger number, the A, okay, the A squared thing, that's going to be beneath the Y, right? Because your Y-axis is longer, so the A, the bigger number, needs to go beneath the Y. Now your vertices, again, vertices meaning the endpoints of the major axis are now going to be on the Y coordinate. The major axis is always the longer one, so if it's on the Y axis, you need to change Y coordinate. And then the same thing with the foci thing. Yeah. Okay, your two focus points now are on the y-axis as opposed to the x. All right, otherwise, everything's the same. Major axis is still 2a. Minor axis is still 2b. It's just the difference between the a and b is now that your a's are on the y-axis and the b's on the x-axis. I'm saying, I just want you to find everything that's already listed up there. I'm not going to worry about graphing it or anything like that. And since everything's centered at the origin today, you don't even have to take the time to find the center. Which as soon as we get into that, then it becomes a little bit more involved. Okay? So when you're doing this, guys, I would assume, the first thing you would want to do, if you want to line it up exactly with the equations that were up there, the first thing I would assume you guys do is label which one's a squared and which one's b squared. Obviously, the one that's bigger needs to be your a squared to tie in exactly with what the formula is. And I'm talking about denominators, right? So 25 obviously should be bigger than 9. I do numbers. All right? So in terms of doing this, I would probably identify that first, okay? Now, for all the numbers I need, I'm going to need the value of A, the value of B, and the value of C. So I would go ahead and get those out of the way first, because then once you have those, you can just kind of fill in exactly what needs to be filled in to get all the numbers here, right? The major, minor, axis, length. All right, so I hope you understand, right? A should be what? 5. B should be 3. And then the c squared thing doesn't change, guys. The c squared equals a squared minus b squared. So, 4. I know, I'm getting that. I'm just going to write out. I know some people don't. Okay? All right, so then you go, okay. So, since you know that this one's going to be more vertical, like if I just did a sketch, it would obviously be longer that way. My vertices would be, there's one vertex, there's another one, and the two focus points would be there and there, somewhere. Okay? That would be just there to maybe help you visualize it, just so you remember when you start doing the numbers here. Like a lot of people can remember like the vertices, especially if it's centered at the origin like we're doing now, that one of these numbers is 0 and the other one is plus or minus a. All right, but if you visualize it, you'll realize that this all has to be on the y-axis, so you should have 0 minus 5 there. Okay, and this is on the y-axis, this is y. The focus points, plus or minus c, 4. Major and minor lengths. The major one should be 2a, so this is 10. Minor one is 2b, so that's 6. So what these numbers do is if I were to graph this, this would be pretty easy to graph. Because this is telling me from here to here, that length is 10. From here to here, that length is 6, which kind of helps you graph them. Okay? For this one here, you're not graphing. All we are asking to do is find that, and that's it. That would be a pretty basic problem. It's just getting you to identify the correct spots for the numbers, be able to find C the correct way, and so on. Okay? So, with this is the same kind of idea, right? I'm just finding the vertices, the focus points, major, minor one. And this one, yes, be horizontal, right? This one would be more horizontal because the bigger numbers underneath the x. So if you were to line it up with exactly what the equation was, this now would be your a squared, that would be your b squared. Right? And just like the other one, I would assume you get a, b, and c first. So a is that, b is 4, c squared is 49 minus. What's 49 minus 16?
33.
So this is square root of 33. If you get something like this, because there's going to be quite a few guys that you will have square roots in there, things like that. Leave it as a square root. Don't make it a decimal. Okay? And don't even worry about that. All right? So now this is all I need to do my answers. Right? My vertices now The vertices are on the x-axis because I know the bigger numbers underneath the x. So the plus or minus goes from the x, 0 is on the y. Okay? Focus points, again, the x-axis is where the two focus points are going to be. Right, there's one, there's the other. So this is plus or minus square root of 33, 0. Major axis is still 2 times whatever the larger number is between A and B. That's 14. Minor is 2 times the smaller one, which is 8. Like, all this is, it's the measure of how close to a circle the ellipse is. That's pretty much what it comes down to. The way you find it is you use the values of C and A. Okay? Because again, C would be how you're finding the focus points, and A would be how you're finding the vertices. So those are the two that you're going to put into a ratio. Alright? If this was a circle, they would be basically on top of each other, so there would be no deviation. Which means that the closer this value is to 0, the closer it is to a circle. Okay? Alright? So just to show you differences, you can do a sketch. The big idea here is you get eccentricity measures how close it is to a circle. The closer this number is to 0, closer it is to being a circular shape. It won't be a squash. Alright? C is always the same as the other ones. It's still C squared equals A squared minus B squared. That should solve out for you. And the A is still whatever the bigger number is, square root of. Okay? Because the A is still along your major axis. Alright? And if you just want to see something, that's just. Okay, so 2 things. You consider moving straight. You're not going to be doing like completely square. That'll come into play when we do the shift, and we actually have centers that aren't at the origin. The thing is with these, what you got to remember is this side over here, in terms of the equation, we want to be equal 1. So unless you need to move a squared term to the other side, because your x squared and y squared need to be on the same side of the equation. The only thing you need to do is get this side to be 1 by either multiplying by something or dividing by something. Okay? So with this one here, obviously you're going to have to multiply both sides by 4 to make this equal to 1, correct? Like 1/4 times 4 would be 1, right? Right. So over here you'd have 4 times 1/2, which is y squared over 2 would be that one. 4 raised 1/2. Now, the only other thing you have to do with this one in terms of getting your whole a's and b's is remember, in terms of the equation, you have x squared over a number, y squared over a number. That's fine. I've got y squared over a number, but here I don't have x squared over a number. So what you have to do for this one here, guys, you have to make that into x squared divided by something.
Why?
Now, 2x squared is not the same as x squared divided by 2. You don't have to
0.5.
Okay?
Yeah.
So instead of actually being this way, what do you mean?
Yeah, why not? Can't you
No,
do that? Did I say that correctly?
Because the A and B come from me not having a number next to it. Like, now I look at it, that's going to be my A squared, that's my B squared.
I mean, technically, x squared over 2
is 1/2 x squared. Which is not the same
X
thing
squared
as
and
2x
1/2.
squared.
Oh, okay.
Look at that. 4x is the same thing as x over 1/4. You divide by a fraction, you multiply by the 6. 5x is the same thing as x over 1/5. That's why I'm writing that. And you guys, you have to have it written that way, because for us to be able to just pull numbers out, like for you to visualize it, You need to have just a single number on the bottom with nothing next to the x squared. Okay? So like if you had something where it was like, 3x squared over 4, that needs to become x squared over 4/3 in terms of you pull numbers out. Okay, you kind of drop that number down to the bottom, like we normally. Okay, so now, once you're there, you go through this problem like anything, right? A is the square root of the bigger number, which 2 is the bigger number, so A is the square root of 2. Smaller number is 1/2, so B is the square root of that. Right? C squared is A squared minus B squared. 2 minus 1/2 is 3/2, correct? So C is 3/2. Alright, now these numbers right here, for like the 2 focus points in the vertices, I'm going to lead with the square roots of. When I do the eccentricity part, you can do that as a decimal, that's fine. Okay? But like when you do the vertices, now, and again, since the bigger number is below the y, so that means it's going to be the y coordinate that is changing for these. All right, so my vertices would be 2 or 0 plus or minus square root of 2. All right, because the vertices come from the major axis number, which is the A. The 2 focus points come from the C. So again, it's on the y-axis, so that's why I'm going to put that number as plus or minus. Okay? And then for this part, right, it's C over A. Now look, you don't need to leave this as an exact number. Because this is a measurement, you want to be able to actually see decimal-wise what it is. So you actually want to go ahead and divide those out. Like, what is that? This needs to be done in the calculator. What's square root of 1.5 over square root of 2? What does that divide out?
Square root of 1.5 over 2. 0.866.
And that would be all this is asked, because again, I'm not graph. We'll graph the last one, it's not. I just wanted to do one that had like a weird fraction thing in it, so you can actually see it, at least to deal with it. Attempt to. Okay. So this means like if I were to look at this, I know this graph, it wouldn't really be circular, it'd be kind of oblong because that number is pretty close to 1 as opposed to 0. I'll let you do, guys. Like I said before in the last one, right? You just want to do whatever makes that 36 a 1. You'd be dividing everything by 36. So this becomes there 1. Now look.
1 over 4x squared.
So 9 over 36 is
X squared 4.
4. This is okay. So the whole point of doing that is, and guys, remember these worked out nice because 9 and 36, divide 4 and 36, so on. If it doesn't divide evenly, then you'd be dealing with fractions on the bottom. Like if this was a 8 or something, you'd have 36 over 8.
No, you wouldn't do that to us, right? We should make them all.
So just like I've done the last one, okay? I'm doing the focus points, the vertices, the eccentricity first before I do the graph, because all the numbers I use for the graph are going to come from there anyway. So the A is, again, square root of the larger number, so the square root of 9 would be 3. The B is the square root of the smaller number here, that's 2. And then C squared would be that, so C is square root of 5. Okay? So, in terms of our graph, right, the vertices, is this one more horizontal or vertical? Vertical, right? Because bigger numbers underneath the y. So this is 0 plus or minus 3. 2 focus points are going to be 0, 5.
It It means it's more vertical, is that what you said?
Yeah,
It's the big
underneath.
numbers underneath.
All right, so the E1 would be C over A, square root of 5 over 3. What is that? 745. Okay. And the last thing with the graph. Now, guys, when you graph these, the things that I would expect to see are going to be 4 points for like the vertices. Okay, now I know there's only 2 vertex points, right? But these 2 are on the major axis. All right, so I'd expect those 2 points to be there. The other 2 that, like I said, they don't consider vertices in terms of these problems we've been doing, need to come here. But this is positive B and this is negative B. So what we're doing right now. So if our B is 2, that's a positive 2, negative 2. Right? And then what you would just do is kind of just connect them in some kind of circular fashion. That's not too bad. And then the last thing I would honestly like to see is you graph the 2 focus points. Right? Like square root of 5 is a little bit more than 2. Right? So it's going to be somewhere you can have 1 focus point there. You can have 1 focus point. Okay? But the big thing when you graph is that you have these at A, that's negative A, B, negative B, or flip if it was more horizontal, where the A and B along the X, we have these two as well. Okay? Just remember, guys, if it's not in the proper form, you got to get this side to equal 1.